this section, we're going to be talking about measures of variability. When we're talking about variability, we're trying to determine the difference between values in a data set and the center of that data set. The most common measures of variability are variance and standard deviation. When we're talking about variance, we're trying to determine the average of the square difference from the mean. On the other hand, when we're talking about standard deviation, we're trying to determine the square root of the variance. By definition, the variance is the square root of the standard deviation. I'm going to be providing some examples of both. When it comes to the examples that I'll be providing, I'll be using Kaggle again to download daily statistics for trending YouTube videos. I'll be using Kaggle to download trending YouTube video statistics. So first thing I need to do, I need to import my modules. And the next step is to read the CSV file and load it into the dataset. As you can see here, I forgot to import pandas. This time it worked. Once imported and loaded the dataset, we can see we have a few columns: video ID, trending date, title, channel title, category ID, publishing time, the tags, the number of views, the number of likes, the number of dislikes, comment counts, thumbnails, and some other columns in the dataset. The last column, DT, is the column that I just created to convert my string into a datetime object. When I look at tables, I get a little confused. A lot of times I like to be able to visualize them. So I'm gonna insert some code here that I wrote real quick and was able to generate a scatter plot, likes versus dislikes. Likes are the markers in blue and dislikes are the markers in green. As you can see here, my x-axis is the number of views and my y-axis is the number of likes and dislikes, a million. So it seems right off the bat, the higher the number of views, the more than likely you'll have likes. And it seems like even if a YouTube video has a high number of views, the number of dislikes seem to be, in general, as a trend, a lot lower than the number of likes. This is fantastic. Now I know what I'm working with, and I can have a clearer picture when I use the formula for variance and standard deviation based on the following data set. Before I do, I'm going to talk about standard deviation. So again, the standard deviation is the square root of the variance. By definition, the variance is the square of the standard deviation. So I'm going to use a NumPy example. So first, I'm going to create a NumPy, an array with the following values. I'm going to print the standard deviation of the array, and I'm going to print the variance of that array. So right off the bat, as you can see, very easy, especially when I use NumPy to determine the standard deviation and the variance. To repeat, the NumPy std and var functions are used to find the standard deviation and variance, respectively, of values in an array. Now, the dataframe.std function is used to find the standard deviation of values in a data frame, and the dataframe.var is used to find the variance. Perfect. So now if you remember, I loaded my dataset, usvideos.csv, into a data frame called df. So I'm going to continue from here. And now if I type print df.standard deviation, I'm able to find the standard deviation of values in a data frame. In this case, these are the standard deviation values for my data set. As you can see here, views, likes, dislikes, I was able to determine the standard deviation with these. And of course, if I wanted to be a little bit more specific, for example, I wanted to take a look at likes, standard deviation for just likes. I'm able to by specifying over here likes. And as you can see, this value matches that value. Now the next part is variability. Now when it comes to variance, same as the standard deviation. If we print df var, we are able to determine the variance for all our values. Likewise, if we want to be a little bit more specific, instead of standard deviation, we enter var for variance, and as you can see, this value will match this value over here. Last part, I want to talk about mean, absolute deviation, MAD. Now, the mean absolute deviation is the mean of absolute difference between each value and the mean of those values. The MAD uses the absolute value instead of the square root of a sum of squares to avoid negative distances. Now, one would say that MAD has been proposed to be used in place of standard deviation since this corresponds better to real life. MAD is typically a simpler measure of variability than the standard deviation and could prove itself very useful. With MAD, we can implement the same technique as we did in the past. Instead of standard deviation function, we enter MAD. And of course, if we want to look at the mean absolute deviation for likes, as you can see here, this value is the same value as the one that's shown over here. Now MAT, the forecast accuracy, is typically close to the mean square error. MAT is commonly used because it's both easy to compute, have to avoid, well, you can avoid the need for squaring, and easier to understand.